Welcome and hello. This is a video lesson using the HEC-RAS controller. We are going to be exporting data as a .sdf file, .gml file, and .xml file in this lesson. As you see on the screen here, I already have a project set up. I have a single river, a single reach, got an inline structure right here, which I'm going to use for the dam breach. So let's go ahead and just take a look at the cross sections real quick. Here are some cross section data. As you can see, I have that inline structure. And then I have unsteady flow. Actually, it is a constant 1000 CFS flow, but I'm using unsteady flow as my simulation. So let's just go ahead and run that real quick. Okay, so that finished up. Boom. And let's go ahead and take a quick look at some results. So here is the cross section at our different cross sections. This is the inline structure right here. All right, so what we're doing here is going to be exporting a few different files using a few different procedures in the HEC-RAS controller. So to do that, I'm going to open up my Excel file. This is called controller.xlsm. And then I'm going to click on Developer and then Visual Basic. All right, so the first thing you want to do is click on Tools and then References. And I'm going to be using the HEC-RAS controller for version 5.0. In a lot of my lessons and videos that I make, I've been using 6.6, but this is going to be 5.0. Okay, so here we are. And this is 6.6, 6.7 beta, 6.4, 5.0. Okay, there we go. Check that checkbox and OK. Let's go ahead and see which procedures we have available to us. I'm going to click on View menu and then Object Browser. All right, and then for the filter, I'm going to select RAS 5.0 and then click on the HEC-RAS controller class. All right, so these are the list of procedures. First one we're going to look at is Export GIS. So let's check that out. That is right here, Export GIS is a subroutine. It takes no arguments. This subroutine exports the HEC-RAS results to a .sdf file that can be read into GIS using HEC GeoRes. So it creates a file which is going to be in the project directory. It's going to be called project.rasexport.sdf, or instead of project, whatever the name of your project is. And it takes no arguments. It returns no values. It's pretty straightforward. Let's go ahead and see how that's used. So I'm going to close this up and then double click on my sheet 1. So I'll just use this for inputting the code. This is what I just pasted in. So what we're doing here is going to run this subroutine, get GIS SDF file. I'm creating a HEC-RAS controller. I'm going to call this open project subroutine to open my project.prj. After that, it's probably one of the simplest procedures there is. We just call export GIS. There's no parameters, as you can see. And then I'm going to close the controller. So we're going to see what happens when we do that. Let's go ahead and check out the project directory here. This is my current project directory. There's a total of 15 files. So after this runs, we should see a 16th file. Let's just go ahead and run it and then look for that file. And if it's there, let's see what sort of data it provides us. All right, so back to VBA. I'm going to save and then click into the subroutine, and then run menu and run. Okay, I've got this note here says that there are 6 cross sections in the geometry that are not geo-referenced. So one thing about this particular export is that I may need to have some of my features geo-referenced, and in my project they are not. And that's fine. We're just sort of doing a demo anyway. So let's go ahead and see what sort of data we do have. So I'll click OK to that. This is a confirmation that tells me that this particular file was exported successfully. So it's called project.rasexport.sdf. Okay, so let's just check out what we have here. Here's the project directory. Boom, here is the new project file that was just created, our .sdf file. So I'm going to open this up in a text editor. Here is that file. So it gives me the date and time that it was created. There's some header data. There's a lot of missing data, partially because my project's not geo-referenced. So this is probably rather unsatisfying. You'd probably be using this export feature if you had GIS related data, like spatial data with projections and map layers, and this looks rather sparse. Okay, so I'm just scrolling down, and what we have is some reach data right here, it looks like. And then we have begin bounds and then polygons. So anyway, that's it. maybe this is data that you could find helpful. Of course, if your project was geo-referenced, you'd probably have more interesting data to look at than what I'm providing right here. Okay, let's move on to the second procedure, which is geometry underscore get GML. So let's take a look at the information for that. View, object browser, okay, RAS, HEC controller, geometry underscore get GML is right here. This is a function. It is going to return a string, and it's going to take as its one and only argument the geometry file name as a string. This function returns the GML file text for the current geometry file. The argument is the file path to the geometry file. So it's going to be our .g01 file, and it returns a string, which is the contents of the file. So we can create a new file and then print the string that this function returns to a new file. Okay, so let's go ahead and paste this in. What I've created here is a subroutine called get geometry GML file. This right here is the line of code where we're calling the HEC controller using the geometry underscore get GML function, passing it the file path to the geometry file, which I have right here. And then that is going to be the text. So we could print this out just to the intermediate window using the debug.print. In fact, let's go ahead and do that first. So I'll comment out the actual code down below here, which will print it to a file called geometrydata.gml. So let's just first do a preliminary test. I sometimes like to do this if I'm not really sure what to expect. So let's just go ahead and save and then run this. Okay, so here is the XML format, or this is the GML file, but the format is XML. We have an XML namespace attribute right there. Okay, so far, so good. In fact, I could just take this code, this string right here, copy and paste it into my own .gml file, but I do want to automate that process through the script. So let's just go ahead and uncomment out that right there, and then we'll comment the debug print to the intermediate window. All right, so let's go ahead and save that. I'm going to be saving it directly to my project directory. I'm not going to put it inside this HEC directory just because there's a lot of files here. It could get a little bit messy, and there's fewer files here. So this is the directory I expect to see that new .gml file to be created in. Okay, enough talking. Let's go ahead and run this and run. Okay, it's done. Let's see if there's a new file here. Boom, there is. That's cool. So let's go right click, open this up in a text editor. Okay, so here is that file right here. We have what looks like an XML file with some data, not very long at all. That's the total contents of the file right there. A lot of times for XML files, I like to format them with line breaks and tabs so that you can easily kind of see how the nesting looks. So I'm going to do that with this file here. I'm going to select the entire contents of the file and then Control C to copy. Then I'm going to bring up an online formatter. This is just one of many formatters, but it'll clean up the XML. We'll go ahead and leave a link to this URL in the description of the video in case you want to use this one. But I'm just going to Control V and paste, and then just click off. And I think it formats automatically down below. So here it is. If my browser window was a little bit wider, then it does like a side-by-side comparison, like this right here, which I think is a little bit easier to see. But I'm trying to keep my windows a little bit on the small side. So let me go ahead and just select all, Control C to copy all, and then come back to the original file here, select all, delete, and paste. And then I'll save that. So now we can see the structure of the XML a little bit easier, starting with feature collection, bounded by. Here's a feature member, which is a river. So I assume these coordinates here define the XY coordinates of the river reach that I sketched out. That's river A, reach 1. And it looks like that's all I have because it's such a simple model. It didn't even take my cross-section data, but that part could also be because my project is not geo-referenced. All right, so that is the second procedure that I wanted to talk about. I've got my HEC back on the screen here. We're ready to look at the geometry underscore breach param get XML procedure. This is a function. So let's take a look at the breach data itself. Like I mentioned, here's an inline structure. So let's take a look at the breach properties that I have set up. And here they are. Breach this structure And then what you see in the red outline here is the final extents of the breach, which would have a center line at 150, final bottom width of 50, a final bottom elevation of 510. 1.3 to 1 is the horizontal to vertical side slope on both the left and right side. It's going to take 2 hours to complete the breach. All right, so when I perform this last function, it's going to export this data in an XML format. Okay. So I just wanted to show you these numbers so that we can confirm that they are consistent with the exported XML file. So I'm going to go ahead and close that up. We can close RAS completely and sure, save. We'll go up to View and then Object Browser. Now we're looking for geometry underscore reach param get XML. That's this one right here. So what it says, it's a function that returns a string, and that's going to be the string variable listing out the dam breach parameters of the current plan in the XML format. Also, I should probably mention there is a complementary dam breach param set XML, which allegedly you can set dam breach parameters using that subroutine, but I couldn't get this to work, so you're welcome to try. I should also mention that these two procedures are not available in some of the more recent versions of the HEC RAS controller, and that's why I'm using version 5.0 for this video. Okay, so let's go back to the code, and then I'm just going to scroll down a little bit further and paste in this subroutine right here. I'm calling it get dam breach data. We're going to be exporting that data into an XML formatted string. Okay, so what I'm doing is I'm creating an XML variable. It is of data type string, and I don't pass it any parameters. I just say create my HEC RAS controller up here, open the project, export that data as XML. I can print to the intermediate window like we did with the GML file, but I'm not going to do that. I'm just going to write it straight to a .xml file. It's going to be in the same directory that we exported the .gml file, except I'm going to call it breachdata.xml. So let's go ahead and save that and then give it a run. So run menu, run. Okay, looks like it completed. And boom, breachdata.xml. So let's see what that looks like. Here is that file. It looks like an XML file. We can see some of our numbers, like 150 is the center line, station 50 feet is the bottom width. Let's go ahead and clean this up again. So I'm going to go back to that web page that I used previously. Scroll to the top and then just paste in the XML string. Okay, and then scroll down and boom, here it is formatted. So let's paste this back into our XML file, which is right here, and boom. So now we have a list of breaches. This is one breach, and then everything here is our breach data. This makes it a little bit easier to read. I hope you can agree with that. We have a river, a reach, the river station number, center station, bottom width, bottom elevation, left slope, right slope, weir coefficient, piping coefficient, and the duration of time in hours it takes to complete the breach. So that's it for this lesson. What we did was export different GIS and geometry related data and dam breach data from our HEC RAS model into 3 different types of files using the HEC RAS controller.